direction and bearings. Now, bearings are very important. It is how we navigate around the world and how we find things on maps. So bearings can be very, very important. There's two different types of bearings that we use. Okay, we use true bearings. And we have compass bearings. Okay, all bearings start, or true bearings particularly, will start clockwise from north. So true bearings are measured clockwise from north and contain 3 digits. Now, 2 of those digits may be 0. As you can see, we have 000, 045, 090. So those in yellow are our true bearings. You can see north actually has 2 true bearings, 000 and 360. The compass bearings come off the north-south line. And start with that direction, and then whichever way east or west they're traveling. Okay, and that is something such as what's written there. Change my highlighter. So we've got north, northeast, east, southeast, south, southwest, west, northwest. So we might say that northeast is actually north 45 degrees east. So that's how we would look at it. Now let's see these in action. We want to give the bearing for each of the points in this diagram from the origin, which is 0. Let's look at A. A comes out and is 35 degrees from E. So A is 35 degrees from E. Now E is 90 degrees from north. So if we take 35 away from that, we're going to get 55 degrees. And if we want to write that as a true bearing, 055 degrees. And more often than not, you'll find it ending with a T for true. We probably don't need to worry about that today because we're going to be using mostly true bearings. For B, let's look at B. B is 45 degrees down from east. So we have the 90 degrees from north to east plus that 45. So we're going to go 90 plus 45. That's going to get us to 135. And that's already now 3 digits. Let's look at C. C is 30 degrees from west. Now west, if you're going from north all the way around, okay, you go 90 to 100 to 270. So this one's going to be 270 minus 30. And that's going to give us 240 degrees. Again, already in 3 digits. And then our last one is D. And that's coming up from west 70 degrees. So I know all the way back around to north is 360. So if I go 360 and I take away that 70, actually there's a better way to do this. Let's do it a little bit different. Let's actually take that 270 that's at west and add it. Let's add the 70 to that. That's actually going to get us a far more accurate answer of 340. And that's all there is to doing those directions and bearings. Let's look at a slightly more difficult task. We're going to have a ship traveling south for 5 kilometers, and then it's going to go on a bearing of 120 degrees for 11 kilometers. So what we're going to do is we're going to draw this picture. So I'm going to get my pencil and start with a basic north, south, east, west line. Always better if you use a ruler, by the way. Now, we know that he's going to travel south 5 kilometers. So in red, we're going to go down this way 5 kilometers. So let's put in a new dot. We're still east-west here and still south down the bottom. Now, changing the direction, we're now going to go 120 degrees this way to a new line that is 11 kilometers. All right, and we want this to be a 120 degree angle. So hopefully you're following along with this drawing. We've travelled south 5 kilometers. We've now gone 11 kilometers in a southeast direction, 120 degrees. We want to know how far east that ship is from its original starting point. So we've got a couple of things we can do here. We've got our triangle. So we need to do a triangle. Got a right angled triangle. We want to know this one. So X, and in the middle we can find this angle in here. So this angle in here is going to be 120 minus 90. So that's going to be 30 degrees. Okay, so that's the triangle we're going to use to do the first problem. So we know that we have a hypotenuse, so we can't use tan. We have an adjacent side, so we can't use sine, so it has to be cos. So cos of 30 degrees, we should actually start with our formula proper first, shouldn't we? So cos theta equals A over H. So cos of 30 degrees equals X, because that's the adjacent side, over 11, which is our hypotenuse. X is going to be 11 times cos 30 degrees. And if you whack that into your calculator, you should get 9.53 to 2 decimal places. And that's in kilometers. Okay, let's double check that just to be sure. Trust your calculator is on. I want to go 11 cos was 30, close bracket. Okay, and you can see there we have our 9.526, this 6 making that 2 become a 3. Correct answer. Let's look at the next problem. Our next problem is how far south is the ship from its starting point. So we want to add this bit here, which is y, to this bit here, which is 5 kilometers. Okay, we need to add those two together, but we need to find y first. So using the same hypotenuse of 11 and the same angle of 30, we now have the opposite side. So now we're going to use sine. So it's going to be sine of theta opposite over hypotenuse. Sine of 30 degrees is going to be y over 11. So y is going to be 11 sine 30. We whack that into our calculator and we're going to get 5.5. We add that to the other bit. So south equals 5 plus 5.5 will get us 10.5 kilometers. And we should really chuck in a sentence answer for the bottom. That's it. That's how it's done. Let's have a quick look at the calculator for our y. So now we're going to have 11 sine, this time 30, and it's 5.5 exactly. So that's how it's done. Hopefully this video has been informative and helpful. And good luck with your questions. See you in the next video.